And welcome to the last paragraph. We'll be discussing this chapter, which is called Counting and Probability. However, the only thing we're really going to take a look at is the counting part, since probability is Theory D, and Theory D won't be on the test paper. So with that being introduced, let's take a look at the first theory that we're going to talk about, Theory A, which is about tree diagrams, right here. A tree diagram is a way to give you a visual representation of how many different ways there are to do something. For example, here in this example, they say Marcia has 3 pairs of jeans, blue, red, and white. She also has 4 t-shirts. They are red, yellow, purple, and blue. Well, how many possible outfits are there? Well, it all depends on, first of all, which color of jeans does she wear? And if she has chosen that, well, there are still 4 different ways that she can choose the t-shirt, red, yellow, purple, or blue. And if you're going to count them, you will count that there are 12 distinct different ways or outfits that Marcia might wear in this example. Every different possibility is what they call a branch or a tak. And a tree diagram itself is called a boomdiagram in Dutch as well. So, for example, here we have 12 different branches in the end. It's also very easy to now calculate the number of outfits that Marcia can choose from. You're just going to multiply the amount of t-shirts and the amount of trousers, this pairs of jeans in this case. So that's also what the theory says, right? If Marcia can choose from P pairs of jeans, P being a number, and Q t-shirts, Q also being a number, she has P times Q possible outfits to wear, in this case 3 times 4. And if you want to, you can also draw this tree diagram all the way, but I'm personally not a big fan of tree diagrams. Why not? Well, let's show you the next question. Mike rolls 2 dice. If you now want to give a graphical representation of this using a tree diagram, well, you have to draw something like this, right? Because at the start you can roll a dice and you get 6 different results. You throw either 1, 2, 3, 4, 5, 6. And the second one, you're doing exactly the same. So the calculation is not that difficult. It's just 6 times 6. But if you want to draw a tree diagram for that, that's, as you can see, a lot of work. So please do not do that every time. Instead, I would suggest that you're going to use a so-called network diagram for this, ook wel een wegendiagram genoemd. I think a network diagram is for almost all the questions a better or a faster way to give you a visual representation than using a tree diagram. Tree diagram is only nicer if you really want to show which way you have chosen already. But it's, as I said, it takes a lot of work. If you're going to take a look at this network diagram here, the question here was Susan rolls 2 dice and flips a coin. So the dice gives me 6 possibilities. The second dice also gives me 6 possibilities. And the last one either gives me heads or tails. Here in the book they still use kop and munt. They haven't translated to head or tails. So what are the possible outcomes? How many different outcomes are there? Well, the calculation is quite easy. It's 6 times 6 times 2 gives me a possible outcome of 72. If you want to use a visual representation, then please use a network diagram for this. As you can see, this is a lot less work than drawing a tree diagram. That would take up, I think, a whole piece of paper in this case. Well, here you can do this in just a few seconds. So every line right represents one possibility from one point to the next point. So you have 6 lines here for the first dice, 6 lines here for the second dice, and then here either head or tails for the coin that you have flipped. Multiply them, give me the possible outcomes. Let's take a look at an example. Kathleen has a string with 5 lights in her room. The lights flicker at random. The sequence plus minus minus plus plus indicates that lights 1, 4 and 5 are on and 2 and 3 are off. So a minus indicates that they're off, a plus indicates that they're on. How many possible situations are there? Well, if you want to draw a tree diagram, please don't. if you want to draw this, use a network diagram. Or if you don't want to use that, well, just know every light has two possibilities. It's either on or it's off. So the total amount of possibilities are 2 for every light. You have 5 lights, so as you can see, the book says, yeah, just do 2 times 2 times 2 times 2 times 2. Or do 2 to the power of 5, you could say that's the same. So there are 32 different possibilities. But what if at a certain point of time the 2 outer lights stays on and the other one stays off? How many possible situations are there now? The book does draw a network diagram for this one to show you a bit more clearly what this represents. The outer 2 lights, so the one in the beginning and the last one, are on. And the other ones, they can be on or off, right? The question doesn't state what they are. So how many possibilities are there? Well, the first one is on, so that's 1, because there's 1 possibility, times 2 times 2 times 2, you got a 3 in the middle, and the last one must be on again, so times 1 gives me a total of 8 possibilities in this situation. So draw a network diagram if you find this easier to give you a visual representation, right? The calculation you still have to show on your test as well, and that's also always a multiplication of the different possibilities that there are per thing. So here per light. Then the last thing that I want to introduce to you are so-called competitions. And in English they use quite difficult sentences, you could even almost say, for those terms. They could talk about double round robin competitions and single round robin competitions, and the Dutch translation is a lot easier. The first one, a double round robin, is een hele competitie, which means that you play against each other twice, once at home and once away. So to give you an example, you could take a look at the Eredivisie, right? You always play each other home and away. While a single round robin competition, een halve competitie, you only play each other once, maybe at home, maybe away. That isn't mentioned, but there are a lot less matches in that way. Double round robin competitions are quite easy to calculate, because what you're going to do, you're going to take the total amount of teams. So let's say there are 4 teams here. If they play a double round robin competition, they do 4 times 3 is 12 matches. Why 3? 1 less than the total amount of teams. So 4 times 3. Okay? So if I had 8 teams, it would be 8 times 7. If I have 18 teams, as in the Eredivisie, it's 18 times 17. In a single round robin competition, you also take those 2 numbers. So here they use 4 and 3, right? If there are 4 teams. But you have to do it times a half. There are half times as much, or 2 times less, you could say, matches, because you don't play at home and away. Only one of those 2 is possible, which gives us 2 times less matches in total. So for a single round robin, you have to multiply that number times a half. Okay? So here another example. If you have 10 matches, a double round robin gives me 10 times 9. The total amount of teams times the total amount of teams minus 1, which gives me 9. And a single round robin the same, but you have to multiply by a half. Okay. Let's say we're going to make this question a bit more difficult. This example here. The 8 second-year classes at Crossroad College hold a double round robin football competition during the first term, a single round robin volleyball competition during the second term, and a softball tournament with knockout system during the third term. How many matches will they play together? Well, we have to first calculate what the first term gives us, the second term gives us, and the third term gives us, and then we can add all those numbers up, and that are the total of matches that are played, right? So first take a look at the double round robin, the football competition. There are 8 second-year classes, so we now know for our double round robin, we have to do that number of teams times 1 team's less is 8 times 7 is 56 football matches. The second tournament during the second term is a softball tournament, which is single round robin. So that means a half times 8 times 7 gives me 28 matches. And now the book doesn't explain to you how a knockout system works. Well, a knockout system means you battle each other and the loser is out of the tournament, right? You could say there's a knockout in the Champions League, for example. There they play in after the group matches, they have knockout matches. If you lose over 2 matches, you're out. Here, knockout means only 1 match. So if you have 8 classes, how many matches are there in the first round? Well, not 8, right? Because you have to battle another team. So the first round in a knockout match is 4 matches. 4 times 2, because you battle another team, is 8 teams in total. Then 4 of those teams are knocked out and you are left with 4 teams, which have to battle each other, which gives me 2 matches, 2 teams versus 2 other teams. It gives us 2 last teams in the final, you could say. In the final, there's only 1 match, 1 team versus the other team. So how many matches are there in total? 4 plus 2 plus 1 gives me 7 matches in total. Now you have to add them up, right? So the total number of matches that are played are 56 plus 28 plus 7 gives me a grand total of 91 matches. And that concludes the last theory of 6.5 and also the last theory of chapter 6 that we will discuss, because you do not have to take a look at theory D, which is about probability.